Good morning, students. Students, today we are going to learn Rolle's theorem. So what is Rolle's theorem? Students, Rolle's theorem, named after the French mathematician Michael Rolle, gives conditions that tells the existence of an extreme value in the interior of a closed interval. According to Rolle's theorem, student, if a function fx is such that it is continuous in the closed interval ab, it is closed interval, student, and it is differentiable in the open interval ab. Third condition, fa equals to fb, the value of function at the point a should be equal to the value of function at the point b. Then students, there exists at least one value c of x in the open interval ab such that f dash c equals to 0, means the differentiation of the function at the point c should be 0. So this is Rolle's theorem, students. So you can easily understand by the geometrical proof. So student, you can see this is x-axis and this is y-axis, student. There is a function fx defined on a, b. This is a function, student. This curve is a function y equals to fx. Okay, student. This is value a and this is value b, student. So this is function. So let us check one by one all conditions, student. First of all, function is continuous in the interval a to b. It is closed interval, student. A and b both are included. So you can see this is a function, student. There is no break, no slack. Okay, it is continuous. So we can say yes, fx is continuous from a to b. Okay, students, when a and b both are included. So this function is continuous, student. In this figure also, you can see there is a function ab defined on closed interval a to b, and it is also continuous, student. You can see continuous means there should be no break, no slack. Okay. Similarly, student, in this figure you can see x-axis and this is y-axis. This is a function fx defined from a to b, closed interval, and you can see, students, there is no break. Okay, from a to b, it means the function is continuous from a to b. So first condition satisfied, student. Second condition, fx is differentiable or derivable in the interval a to b. It is open interval, student. There is no sign of equal to. There is value x which lies between a and b. So what is the differentiable mean, student? In this graph, there are many points between a and b. at every point we can draw a tangent, student. Okay, it means the function is differentiable from a to b open interval. Similarly, student, you can see here we can take many points, okay, on the curve AB, and at every point we can draw tangent. Okay, so we can say yes, function is differentiable from a to b. In third figure also, students, from a to b we can take many points a, as we have taken p, q, r, s, or more points we can take here on the curve, and every point we can draw a tangent. It tells us that function is differentiable from a to b. This is the meaning of differentiable or derivable. Okay, students. So fx is derivable in the interval a to b open interval. The function fx has a unique tangent at every point between a and b. So this is the second condition of Rolle's theorem. First one, fx is continuous in the closed interval AB and fx is derivable in the open interval AB. Third condition, student, of Rolle's theorem, that value of function at the point A and B should be equal. Means fa equals to fb. Student, you can see this is the graph. In first graph you can see this is the value of fa and this is the value of fb. Okay, suppose the value of fa is 4, the value of fb is also 4 because it is a straight line. You can see at this line the value of function at a is equal to the value of function at b. Okay, students, so we can say yes, fa equals to fb. Similarly, in second graph, student, this is the graph defined from a to b, and this am is the value of function at a, bn is the value of function at b, and you can see both are equal. If suppose in front of AB we are going to take value 5, so value AM equals to 5 and BN is also equals to 5, it means FA equals to FB. Okay, so third condition is also satisfied, student. FA equals to FB, AM equals to BN. Similarly, in third figure also, students, this is A, this is B, and AM is the value of the function at A and Bn is the value of the function at B. So AM equals to Bn shows that FA equals to FB. Now, students, last condition, there is at least one point P on the curve between A and B, the tangent at which is parallel to x-axis, then slope of tangent equals to 0. So last condition, students, from A to B we can take many points. Okay, and from these points there should be at least one point at which the tangent drawn at the point should be parallel to x-axis. Okay, we know that the slope of x-axis is 0. When the line tangent is parallel to x-axis, then its slope is also 0. Okay, so in this graph there is point P at which the tangent drawn at P is parallel to x-axis, it means the value of dy by dx, or you can say f dash c, equals to 0, because the differentiation at this point is 0, which shows the tangent is parallel to x-axis. Students, you can see this point lies between A and B. So there are many points, but there should be at least one point at which the slope of tangent, means f dash c, is 0. In this graph also you can see, student, there is point P. At this point the slope of tangent is 0. This is point C, the value which C, student, at this point. So f dash c is 0 and the C lies between A and B. Similarly, here also in this graph, student, you can see there are many points P. At this point the slope of tangent is 0 and this tangent is parallel to x-axis. Similarly, at point R, Q, S, okay, there are many points, students. So according to the Rolle's theorem, there should be one point, at least one point, at which the slope of tangent is 0. So at P point, students, the tangent at which is parallel to x-axis and slope of tangent equals to 0, f dash c equals to 0, where c lies between A and B. So all conditions of Rolle's theorem satisfied here, and you can see point 1, point 2, point 3 all are satisfied in the geometrical proof. Okay, students? Okay then, students, have a nice day.